Okay, welcome to the second video in exploring and understanding data. So we're going to be looking at sample types. So to begin with, we just have our learning goals. So by the end of this video, you will understand various sampling types. We'll go through a few different with two in particular. And you will be able to perform calculations relating to stratified sampling and capture-recapture sampling. Please make sure you copy those down. Okay, so I'm going to go through the different sampling types. However, you are going to have to take notes as we go, so make sure you pause when necessary. I won't be actually writing all this down, so pause as you go to take notes for each different type. So random sampling will begin. Random sampling, so that would be this first one. Random sampling is the selection of a random sample. So each element of the population has an equal chance of being selected. So an example of random sampling is numbering each item and using a random number generator to select the individuals. Choosing names out of a hat. Using the random generator on a website in order to choose students to answer questions. Random sampling. Okay, so next we have accessibility sampling. So this chooses easily accessible items or people. So it causes bias. It does not represent the population. So for example, a tuck shop survey was conducted on students in the tuck shop line. So there is a bias there in that those kids, because of where those kids are, you may actually end up with bias in the responses for your survey. Next we have systematic sampling. So systematic sampling is a method that uses a system. So for example, every 10th student on the roll, or you go through and you randomly generate every year 10 student, and then you choose every 7th student to go and survey. Then we have quota sampling. So quota sampling is a technique that specifies a particular number of items to be surveyed from portions of the population. So for example, a uniform survey sampled 50 male and 50 female students. So this method can provide a cost-effective and reliable in its prediction if the composition in the sample is approved. So what you want is to make sure that if you are looking at uniforms, you want that they did 50 male, 50 female. You want to make sure you have the same. We generally have a 50-50 split of male-female students in a school. So you wouldn't only survey 5 male and 50 female. You want to make sure proportionally you cover the different groups within that population that you're looking at. Judgmental sampling. So judgmental sampling is used when a sample composition is decided by the person collecting the data. So this method is based on good judgment of the person doing the sample, and therefore it can be biased. So for example, a questionnaire about bus stop positions conducted on people travelling on the bus. So these are people who, travel it all the time, and I guess can give good information about bus stop positions, but they may also be biased depending on what happens in their daily travels and interactions on the bus. Then we have stratified sampling, so it's an important one. It is the process of dividing members of the population into subgroups or stratas before you do the sampling. For example, male or female or age bracket. So the sample would then have the correct proportion of members from each strata. So say we had everyone in the school. If we stratified those, we would have admin, we would have groundies, we would have cleaners, we would have teachers, we would have teacher aides, we would have students, and then each of those would have different numbers against each of those subgroups. And then we would look at doing a proportion of each member. So the more members in there, the more we would take from that strata for our sample. So there's only a handful of teacher aides, but there are more than 1,300 students. So there would be a lot more students in the sample than there would be teacher aides. Okay, then we have cluster sampling. So cluster sampling involves selecting clusters or subgroups within a population as a sample. So the subgroup should be identified and chosen to be as closely representative of the population as possible, otherwise you open up for a possible bias. So for example, a survey on drug use in adolescents was conducted on a sample of students from, Dolby State High School. It's representative enough of adolescents. It's a group of adolescents in a town, as long as it's still across the school, within that school, that cluster sample would be fine. Last of all, we have capture-recapture sampling. So capture-recapture sampling, we take part of the population and it's marked and then released, and then another portion is marked, and if one has already been captured, they receive a different mark. So this is often used for things like fish, a lot of animals, predicting size of populations of animals. So the data is entered into an equation so that you can predict how big the population is. It's really good for animals because you're never going to be able to count the entire population. An example of going out to a lake or a dam and just catching fish, going along, every fish you catch you tag, and then you release them, and then going back a week later and capturing again and basically marking down the number that you capture in that second sample that have already got a tag. And then we use the formula to work out the size of the population. Okay, so let's just do an example. So this is going to be an example for sampling types. Let's have a look. So just having a look at what sample type is used in each situation. So the police breathalyze the driver of every third car. So every third car, they go 1, 2, 3, that car, 1, 2, 3, that car. So that's systematic sampling, definitely. They've got a system, and they've chosen every third car. So 20 of each year level are selected to attend a school function. Well, that is quota sampling. So taking a section of each of those subgroups. And then C, a library hours survey was conducted on the student in the library before school. That is definitely accessibility, one that we're not all that fond of due to its predetermined bias. Okay, so let's have a look at a stratified sampling example. So in this question, a tuck shop survey was to be conducted on 110 members of a school community. The people to be surveyed are in the table below. So you can see here, these are the different populations: management, teaching staff, non-teaching staff, senior students, junior students, and volunteers. And we've got how many in each strata or each subgroup. Altogether, something important that we will note is that we want 110 members altogether. That's how many people they want to survey by the end. Okay, so calculate the number of people to be represented in the survey. So what we need to do is we need to add up all of those. So let's just move this whole thing up a bit so I have some room. So our total members for our population is going to be management, I'm just going to shorten them, otherwise I won't fit them in. Teaching staff, non-teaching staff, senior students, junior students, and volunteers. So it's going to be 14 and 65, 18, 470, 380, and, oh, sorry, 380 and 5. So if we add them all together, we get 952. So we can just fill that in here, 952. Then we need to have a look at who's going to be surveyed. So to be surveyed. Oh. Now basically we're going to use this formula. Let's have a look. So the number per strata is going to equal fraction of strata and multiplied by the number required. So let's have a look. We'll start with management. So for management, the fraction of the strata is going to be, so there are 14 in management out of 952 in the population, and then we're going to multiply it by the 110. So that's the number required. Remember we looked up here, that's why we circled 110. We're going to run out of space here. Okay, and then when we calculate that, we get 1.617647, and it continues on. Okay, and so we're going to do that same thing for each of these. So again, I'm just going to move this up. Okay, so teaching staff. Is going to equal 65. So 65 teaching staff out of 952 in total. And we want 110 surveyed in our sample. So that is 7.50504, and it keeps going. Okay, I am just going to do a quick little note over here. Actually, we do have that written down. So let's move this right up, because we actually have them here. Move this up. Sorry, belongs under there. And let's just look at doing another one. So non-teaching staff. So that's, when we have a look up here, non-teaching staff, that was 18. So we could get that from the table. So 18 out of 952 in total in the school. And we'll multiply it by 110, because that's how many we want in the sample. And we end up with 2.079831. It keeps going. Now our senior students, and that's 470 out of 952. So because that's a much larger number, 470, than any of the others so far, we would expect that the number that will actually be surveyed will be a lot more than it has been so far. And when we calculate, we find that it is. It's 54.3, I'm running out of room, 067, 2, and it keeps going. So it's supposed to be dots. Okay, and then I might just go off to the side here. We have our junior students. I'll just do it like that. Now, junior students are 380 out of our 952, multiplied by 110. And that gives us 43.9075. And it continues. And last of all, we have our volunteers. And they're just going to be 5 out of 952, and we'll multiply by 110. And that gives us 0.57773, and it continues. Okay, so here's where we get, we need to get a bit creative. So let's start with the one that is obviously a bit of an issue, and that's volunteers, because it actually says we need just over half a person. Now that's not going to happen. So the volunteers are going to be 1. We're going to need to round that up to 1 person. Then we'll go through and we'll just have a look at all these numbers and we'll apply our rounding conventions and see what we end up with. Our junior students, 43.9, we'll round that to 44. Our senior students, we have 54.3, so we'll just leave that at 53, we will leave that at 54. Then our non-teaching staff, we've got 2.079, so we'll leave that at 2. Our teaching staff, 7.516, so we might go to 8. We'll see what we end up with. And then management, 1.617, so technically management needs to go to 2. Now what we need to do is we need to actually add them all together. So 1 plus 44 plus 54 plus 2 plus 8 plus 2, and see what we get. And we actually get 111, which is too many. Now, what I need to do is have a look at where I should cut that down. Now, to be honest, I look at management and teaching staff maybe. Non-teaching staff at 18 gets 2 people. At 14, 1.6, we'd probably leave that at 2. Our teaching staff, though, 7.5, we could probably leave that one at 7. Now, if I up this one to 2, 14 and 18, that seems quite reasonable. It's only 4 people less. Keeping it at 2, bringing it down to 1 is the same as volunteers, which is only 5, and the proportion doesn't seem right. So I think teaching staff is where I'll take it from. So what I'll do is I will go back and I will change teaching staff to 7, and that will leave me with 110, which is what I want. I've just run out of room to actually do the addition calculations for you. Yeah, and then that way we know exactly how much. So I might just do a quick pull down so you can see what proportion of the total is each group. So that was our fraction that we worked out for each one. So that was 14 out of 952, 14 out of 952 for management, 65 out of 952 for teaching staff, 18 of 952 for non-teaching staff, and so forth. And then it asks how many from each strata or group should be surveyed. So that would be our answers down here. This is how many. And we just do that double check of adding them up to make sure we actually end up with the number that we want, because we often have to round. And sometimes you do need to make that decision. And that decision needs to be based on proportion. So your answers still need to be proportionally the same. You can't have one with a much larger fraction having a similar number, or a much smaller fraction having a similar number to another group, because of the way that you round. So just be very careful there, and be able to explain your actions. Okay, so now we'll go into a capture-recapture example. So these are the two that you need to be able to calculate. Now what I'll give you initially is the formula, because when we went through the definition of this, I did tell you that there was a formula that once we did our two samples, our first sample and then later on our second sample, we needed to then use the formula to estimate the population. So this is your formula. So let's just run this down. So basically we've got tagged initially. So this is when you first go out and that first sample, how many did you actually tag? This population is the entire population. That's what you're trying to find. Over here, the number tagged recapture is when you go out that second time and you choose another sample and you have a look at how many you capture in the second sample that already have a tag from the first one. That goes here, and then we put down the size of our second sample. So however many you caught and looked at the second time you went out. Okay, so let's have a look at the question. A student wanted to know the approximate size of the mouse population at Marumba. They decided to use the capture-recapture method. So they tagged 120 mice in the first sample. So they went out, caught 120 mice and tagged all of them and let them go. The second time they went out in that sample, they caught 90 mice. So that was the size of their second sample, 90 mice. And of those, 30 had been previously caught. So let's have a look. 120 in our first sample. And then our second sample, there were 90 in total and 30 had been previously caught. Okay, so what do? We start by writing our formula. So tagged initially over the population, which is what we're trying to find. And then that's going to equal the number that were tagged in the recapture over the size of the second sample. Now, we can get all of this from our question. So tagged initially, 120 mice. Population, we don't know. And then over this side, number tagged recapture. So when they did the second sample, they caught 90 mice and there were 30 that had been already tagged. So the number that were already tagged in the recapture was 30. And the second sample, they caught 90 mice in total. So, what do we do there? So, what we do... Okay, so the easiest way to do this is to cross multiply. So that means this one by this one and this one by this one. So I'll just dot that in. We just cross multiply. So that will become 30 times P and 120 times 90. Then all we do is, if we're going to do 30 times P to get P on its own, we're going to divide both sides by 30. Because we're multiplying, we're going to divide. So this will just be 120 times 19. We'll just divide the whole thing by 30. And then when we put that in the calculator, we go 120 times 90, that gives us 10,800. And then we divide that by 30, and that gives us 360. So therefore, well, actually, I'm not really going to fit, am I? Let me move that up. Therefore, approximate size of mouse population at MSSC is 360 mice. And that's it. Alright, so what I want you to do now is to go and do the types of sampling worksheet. So there are a couple of questions for types of sampling, and there are some stratified sampling, capture, recapture. It looks slightly different to the picture I've got here. There's a few more questions in there now. But just make sure you go and work through that. I'll give you some practice on these types of questions.